So I've been waiting to teach this lesson all year. It's one of my favorites, and it's the second lesson, last one, for functions, tables, and graphs. And the I can statement is I can graph functions, and this is the fun part. You know, if you haven't liked math in the past, or if you've loved math in the past, I've found that graphing functions is something that everybody tends to enjoy. If you get into it, if you let yourself enjoy it. So here's an example. We have to graph the function y equals 3x plus 1. Quickly recapping, how do we know it's a function? Because this is the rule portion. This is the rule. This x is the input. Y is the output. And no matter what we put in for the input, no matter what number we put in, we're only going to end up with one output. Only going to end up with one answer. And because of that, we know it's a function. Let me get rid of all this junk here now. Here we go. So one way that you can start this is you need to get a set of points that you can graph. And so you can choose any numbers you want for x. It doesn't matter. Whatever number you choose to put into this, you're going to get a value for y. I took the liberty of choosing -4, -1, 0, 2, and 4 for our example. And so what you do is you take the rule, you write it down, you choose some numbers for x, and as a general rule of thumb, choose a few negative numbers, 0, and a few positive numbers. Plug those into the rule. So I chose -4 for my input, or x is my input. This is my function rule. This is my output. Okay? And then I do the math. 3 times -4 plus 1 is -11. Because 3 times -4 is -12 plus 1, -11. Now this part right here though, this is our x, y coordinate so that we can graph this point. And so our x is -4 and our y is -11. So then when we get to our graph paper, we can graph it. Similarly with this, 3 times -1, we plug that in. Remember, I just chose -1. It's the number wasn't necessarily given to me. So -3 plus 1 is -2. So this must be -1, -2. Okay. 0, that's easy, 1. So 0, 1. Let's see, 6 plus 1 is 7. So 2, 7. So what I'm doing here is I'm plugging in these numbers still. 3 times 4 is 12 plus 1 is 13. Just doing the math. So 4, 13. Okay. So now what I've done is I've taken my function and I've plugged in 5 different numbers. Generally, a line, you only have to have 2 points for a line. I like to do at least 3 just to make sure that I didn't make a mistake. And in the first problem that you have to solve in your worksheet, they're going to give you the numbers for x. But from there on, you're just going to have to come up with your own numbers for x. Okay, so we calculated all these points, and the way we calculated them was we plugged in the numbers that I chose into the function to get our y's or to get our output. So remember, this was a y equals all this stuff. This is what we originally had. So because y equaled all this stuff, y became -11. Y became -2 when x is -1. And I want you to see something here. This is a dependent situation. Y, whatever y is going to be, depends on what x is. When x is -4, only then is y -11. When x is -1, only then is y -2. So it's a relationship between two variables. Okay, so let's plot our points. -4, -11. This is my x side, of course. So I go over to -4, and I got to go all the way down to -11. Right about there. -1, -2 should be right about here. 0, don't go anywhere, go up 1. 2, 7. See, right about there. And then 4, 13. All the way up to there. And I'm going to connect these, and I'm probably going to be really sloppy on my line because I've never tried to do this on my, oh, actually it's not so bad. Never tried to do that on my board before. Okay, so the reason I drew a line through those points is because I know that with this function, I could put in any x number I wanted. I mean, I could put in 1,000,000 if I wanted, and it'd be 3,000,001, 3 times 1,000,000 plus 1. So there's no number that I can't put in. And so I know that even in between these points that I graph, there's, lots and lots and lots of points here that I'm just not showing. So this equation back here actually makes a line on a graph. And I put these little arrows on the ends to indicate that I know this line goes on forever in both directions. It never stops, because this relationship of y equals 3x plus 1 will work for any real number for x. You'll get an answer for y. So anyways, that's one strategy. I'm going to show you the way I do it. So the first problem you do on your worksheet kind of looks like this one. They give you a table. They make it nice and neat and easy. But in the real world, you're not going to have that. So the rest of the problems, I just give you equations and a little piece of graph paper, and I say graph it. And this is what I'm expecting you to do. I'm expecting you to create your own table. And I want to show you how I create a table because it's super fast and easy. I create a table like this. I go x. I draw a little line right here like this. And then I go y equals 2x minus 1. Now, I do this for a few reasons. Number one, first reason I do it is because with this easy of a function, I don't need to write out the math. I can do it in my head. So I pick some values for x. I'm going to start with -2. Then I'm going to go to 0. Then I'm going to do +2. Okay, I have a negative, a 0, and a positive. Then I'm going to just plug them in. What's -2 in the place of x over here? Well, 2 times -2 is -4, minus 1 is -5. And you don't have to do those in your head. You can go off to the side and do your work for that. That's fine. Now I'm going to plug in 0. 2 times 0 is 0, minus 1, -1. Now I'll plug in 2. 2 times 2 is 4, minus 1 is 3. So now I've got these perfect points. I don't even have to rewrite anything. I know I've got to graph -2, -5. Now I got to go 0, -1. And I got to go 2, 3. Whoops. What did I do wrong? These should all be on a line. Oh, I know what I did wrong. I graphed my 0, -1 wrong. Sorry, guys. 0 for the x, go down 1. The y is -1. My mistake. Okay, let's see if I can draw a line through these again. Sort of. I was close. Okay. So this is an example of being efficient. I only did 3 points because that's all I need to do to make sure I was correct. Do you see how I accidentally graphed this point over here when it should have been here? The reason I knew that is because I did 3, and I knew that this point here, something was wrong because they weren't in a line. These functions written in this way should be aligned. And so because I knew it wasn't in a line, I knew I made a mistake and was able to fix it. So that's why I at least do 3 points. All right? The reason I do the table like this is because it saves so much time. I don't have to draw all this stuff out. I don't have to write all this out this way. This is at a bare minimum what I want to see. Okay? Bare minimum what I want to see. At this point, guys, if you're plugging in, for this part here, if you're getting y's wrong because you don't know what you're doing with the math, like y equals 2x minus 1, and you plug in -2 for x, y equals 2 times -2 minus 1. At this point, if you're not getting -5, get with me. You need a little assistance. But I'm expecting more than half the class is going to pretty much do these easy ones in your head. That's fine. I have no problem with that. As long as you're writing out your table, I'm a happy teacher. All right, guys, best of luck to you.